Welcome to all. Myself Lekana. I am from Sri Venkateshwara College of Engineering from the Galvin section, subject maths, and the topic is Markov analysis. Campex ID is 24EC3035. Markov analysis. Welcome to the world of Markov analysis, where we are unravel the secrets of probabilistic modeling, discover its applications, benefits, limitations, and the step-by-step process involved. Questions and solutions with Markov analysis. Are you wondering how to predict the next step in a complex process? Markov analysis can help by analyzing the probabilities of transitioning from one state to another. We can provide data-driven insights and solutions. Let us guide you through power of Markov analysis. Definition of Markov analysis. Markov analysis is a powerful statistical technique that allows us to predict future events based on the current state. It leverages the Markov property where the probability of transitioning to a new state depends only the current state. Applications of Markov analysis. Financial forecasting. Markov analysis can be used to forecast stock prices, identify market trends, and model economic scenarios. Customer behavior analysis. By analyzing the customer interactions and purchase patterns, Markov analysis helps business optimize marketing strategies and improve customer retention. The automated speech recognition. Markov models are widely used in speech recognition system of accurately spoken language into written text. Limitations of Markov analysis. Assumptions of stationaries. Markov analysis assumes the transition probabilities remains constant over time, which might not hold true in certain real-world scenarios. Memorialize properties. The property disregards the history of events, potentially leading to information loss of previous states have to significant impact of future state. Data requirement. Markov analysis requires reliable and sufficient data to accurately estimate transition probabilities, which can be challenging to obtain in some cases. Complexity. Large Markov analysis with multiple states and transitions can become computationally complex, requiring advanced algorithms for efficient analysis. Steps in conducting Markov analysis. Data collection. Gather relevant data and determine the specific states to be analyzed. Transition matrix construction. Create a transition matrix that quantifies the probabilities of moving from one state to another. Steady state analysis. Calculate the steady state probabilities of each state, indicating the equilibrium. Case study Markov analysis in a business. Problem identification, transition matrix creation. Problems identification. Analyze the customer feedback data to identify service related issues affecting the customer satisfaction. And transition matrix creation. Create a transition matrix to model the probabilities of transitions between the dissatisfieds. Let's see the problem on this. A petrol station owner is considering the effect on his business of a new petrol station at Goas. Currently, of the total market share between Shahpur and the Goas. Shahpur has 80% of the market and Goas has 20%. Analysis over the last week has indicated the following probabilities for customers switching the stations they stop at each week and the Shahpur 0.75 and the Gauss also 0.75, Gauss 0.55, 0.46. What will be the expected market share for the Shahpur and the Gauss after another 2 weeks have passed? Would be the long run prediction for the expected market share for Shahpur and Gauss. Let's discuss about the solution. First, we have to let, and the second step is state one, that is Shahpur, And the step 3 is state 2, and that is Gauss. And the step 4 is we have to the initial system state S1 is equals to 0.08 and 0.20, and the tangential matrix P is given by, and the next step by P is equals to 0.75 and the 0.25, 0.55 and the 0.45. Hence, after 1 week has elapsed, the state of system S2 is equals to S1P. P means 0.75 and 0.25 and 0.55 and 0.45. S1P is equals to 0.71 and 0.29. So after 2 weeks we have elapsed to the state of system S3 is equals to S2P 0.69 to 0.308, and the note here that the elements of S2 and S3 are to 1 and the requirements are state 1, state 2 and the P. Hence, the market shares after 2 weeks have elapsed are 69.2% and 30.8% for Shahapur and Gurs respectively, assuming that in the long run the system reaches an equilibrium x1 and x2, where x1 and x2 is equals to x1 and x2 into p, and the x1 plus x2 is equals to 1. We have that x1 is equals to 0.75 x1 and 0.55 x2 into 1. x2 is equals to 0.25 x1 and 0.45 into 2, and the 0.75 x1 plus 0.55 into 2 is the equation number 1, and x2 is the equation number 2, and x1 plus x2 is equals to 1, and this is the equation number 3. From the equation number 3 we have that x2 is equals to 1 minus x1. So substituting into 1 equation 1 we get x1 is equals to 0.75 x1 plus 0.55 into 1 minus x1, that is 1 minus 0.75 plus 0.55 into 1 is the answer is 0.55. That is x1 is equals to 0.55 dividing by 0.80. It is equals to 0.6875. Hence, x2 is equals to 1 minus x1 is equals to 1 minus 0.6875 is equals to 0.3125. Note that as a check we have that these values for x1 and x2 satisfy equation 1 minus equation 3, 2 within rounding errors. Hence, the long run market shares 68.75% and 31.25% for Shahapur and the Gauss respectively. And finally, the conclusion of this topic. Markov analysis is a powerful technique that provides valuable insights and predictive capabilities across various industries. Understanding its application, benefits and limitations, and along with following the proper steps unlocks a world of possibilities for decision making and the optimization. And the video has ended. Thank you guys.